This video is in the chapter of diagonal and trace of matrices. Okay, in the previous video we introduced these three properties of the trace of matrices. So the trace of A plus B is equal to the trace of A plus trace of B. The trace of K A, where K is a scalar, is equal to K trace of A. And third one, the trace of A times B is the same as the trace of B times A. We provide a proof for this first property. So now we're going to provide a proof for the second one. Okay, so we pick this matrix A, where A is Aj, right? And we multiply matrix A by K. So we are going to get Kij, right? Okay. Now the question is, what is the trace of, not of A, the trace, what is the trace of Ka? So the trace of Ka is the sum of K times A. I'm going to change the letters here, Jj, okay, where J begins in 1 and finishes in N, right? Do not forget, please check the previous videos for what the trace is. You're adding the diagonal entries, okay? Okay, so this is the sum of K, A, J, J, but by those properties of these sums, this is the same as the K sum of A, J, J, right? Okay, but here, what you have here is K, and here you have the trace of A. So the trace of Ka is equal to K trace of A. That concludes the proof, okay? So we provide a proof for the trace of K, where K is a scalar, Ka is equal to K trace of A. Okay, now we have the third property. Trace of AB is equal to trace of BA. Okay, let us provide the proof for this third property. So let us say that AB is the matrix Cij, and let us say that the matrix BA, I have to change the letter here, is Dij. Okay, so I prefer to do it directly. Okay, let me pick this. So what is the trace of AB? So the trace of AB will be the sum of this C, but this time II, right? Because we are talking about the trace, beginning in 1 and finishing in N. But Cij is the product of this A times this B, right? So this will be the sum, the product of two sums, right? Of A Ik times B Ki, because this is a product, right? So if this matrix is M times N, this one has to be N times something else. Okay, so this is the product. Okay, and now the sum times the sum of Aik Bki, we can commute this here, right? That is a property of this sums. Okay, so we can say this is the same as the sum times the sum of bki aik, right? From k1 to n, from k1 to n. Okay, but what is the sum, the product of the sum of bki times aik? Well, that is the sum of b times a, right? B times a. So that's the sum of d, but I cannot use ij. This is the matrix. Here I only need the trace, right? So from k equal to n, the sum of d kk. Okay, and what is this? Well, this is the trace of, we said that dij is ba. So this is the trace of ba. So the trace of AB is equal to the trace of BA, and that concludes the proof. So this third property is also proved.